Previously, we had looked at the formulas for the sine and cosine of alpha plus or minus beta. And now that we have those formulas, it's going to be possible to derive formulas for the tangent of alpha plus or minus beta. Now, all of this is going to begin by using an identity. Recall that the tangent of some angle would be equal to the sine divided by the cosine of that same angle. So if we've got the tangent of alpha plus beta, we can actually rewrite that as the sine of alpha plus beta divided by the cosine of alpha plus beta. And these two things, we actually have formulas for these in a way that we can split up the alpha and the beta. Okay, so I'm going to recall those. The sine of alpha plus beta, the sine of alpha plus beta is going to be equivalent to this, and the cosine of alpha plus beta is going to be equivalent to that. So I'm going to go ahead and rewrite this. All right, the sine of alpha plus beta is going to be equal to the sine of alpha multiplied by the cosine of beta plus cosine alpha times sine beta. And cosine alpha plus beta is going to be equal to cosine alpha times cosine beta minus sine alpha times sine beta. Okay, so we can expand all of that out. It looks a lot larger, and it's going to even look a little bit larger in our next step, but it will end up shrinking back down. And in a really neat way, it's going to come all the way back to using just tangent. It's not going to have any sines or cosines in there. All right, so our first big step here is going to be to divide every term by cosine alpha, cosine beta. That means that this right here, which is a term, is going to get divided. This as a term is going to get divided, and so is this, and so is this. So we're going to be dividing all four of these parts by that. So it's going to look a little bit big here. All right, so we got the sine of alpha, cosine beta, which is just this, and that's going to get divided by cosine alpha, cosine beta. This piece here, we then have addition, cosine alpha, sine beta, divided by that, cosine alpha, cosine beta. We then have our big fraction bar, so this is just the top. All right, cosine alpha, cosine beta, divided by cosine alpha, cosine beta. So that is taken from here. The denominator again is taken from there. Subtract the sine of alpha times the sine of beta divided by the cosine of alpha, cosine of beta. So there's a lot going on here. But when we do that, a lot of things are actually going to cancel out. In the first fraction that we have here, cosine beta is going to cancel out with the cosine beta that we divided by. So those are out. Over here, we're going to be able to take out cosine alpha and cosine alpha. They will cancel. Down here, everything cancels. Everything cancels. That means that is going to be equal to 1. It's going to be equal to 1 whole. Here, we are going to not be able to cancel anything. We don't have anything that would be an exact match there. Okay, but we are going to notice that we have a sine alpha over a cosine alpha, which means that can be simplified down to a tangent alpha. And this part right here can be simplified down to a tangent beta. Likewise, this is tangent beta, and this is tangent alpha. Okay, so we can actually condense everything down fairly small now. This all would be equal to, I'm going to try and squeeze it into the space here. Right here, the sine and the cosine will give you that tangent alpha, because they both use that angle alpha. We're going to have plus, this will be tangent beta. All right, so that would be the numerator. That's the whole top simplified down. This just became 1. That is simply going to become 1, and then we're going to subtract a tangent alpha and a tangent beta. Those two will be multiplied together. They're side by side multiplication. All right, so tangent of alpha plus beta. We went through a lot of steps to get there, but eventually we came back to having some equation that separates the alpha and the beta and keeps everything in terms of tangent. All right, so what I'm going to do next here is just summarize our findings. Just go ahead and simply state that the tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta divided by 1 minus the product of tangent alpha, tangent beta. Okay, just go ahead and summarize everything we did there so we can see these side by side. Of course, these are equal to each other. And for tangent of alpha minus beta, instead of going through the whole process that we did for the first one, what we're gonna do is just substitute in a negative beta where we see beta. We're just gonna substitute that in here and then see how that works out. Now, it's actually gonna turn out to be really easy because if we recall something a little bit earlier that we had done, the tangent of a negative angle measurement is equivalent to the tangent of that positive angle measurement, but with a negative out front. It's almost like you can move that negative to the front. Now, technically, that is not what we're doing, but visually, that's how it looks. If you have a negative angle in here, you can actually just put a negative in front and then let that be a positive inside. Okay, so if we take a look at this, and imagine that everywhere we had a beta, we actually had a negative beta, we can move that negative sign out front. Okay, so that has nothing to do with tangent alpha. We'll leave that alone. But here, if that were a negative beta, that negative can move out and give us subtraction. We're gonna end up with subtracting the tangent of beta. Okay, for the bottom, nothing happens to the 1. If this beta is negative, we can move that negative out, and when it moves out, it's gonna change that into a positive. So we get plus tangent alpha, tangent beta. For example number 1, it looks like we have this massive expression that we need to evaluate, right? Looks pretty crazy here. However, that is actually going to fit the tangent of alpha minus beta. It's going to fit that structure. That's what we're looking at over here. So pay close attention. We've got a minus. We've also got a 1 plus on the bottom. Okay, so we got a minus and we got a 1 plus. You're also going to see you have an angle measurement here, which will be alpha, and you have an angle measurement here, which will be beta. Okay, so our alpha is the 4 pi over 3, both of those spots, and our beta is going to be pi over 12, each of those. So this whole massive expression can actually be simplified as the tangent of alpha minus beta, which will be 4 pi over 3 minus pi over 12. Okay, so that's actually what we need to work on. And since we have both of the angle measurements, we can go ahead and subtract them. We can figure out what that is as a single angle. Okay, let's do that as a little bit of side work. We are going to need a common denominator, which will be 12, so we can go ahead and keep this fraction. All right, and then the first, to get the 12 on the bottom, we need to multiply by 4. That will give you 16 pi over 12. Okay, so now that we got a common denominator, we can subtract. That would give us 15 pi over 12, which does reduce, because these are both divisible by 3, reduces to 5 pi over 4. So our actual problem is really just, what is the tangent of 5 pi over 4? What is that equal to? Okay, so in the traditional circle we've been using here, 5 pi over 4 is going to be located right here. It's going to be 1/4 of a pi past. That would be at 225 degrees, which gives us a reference angle of 45 degrees. So I'm going to be using that. And what I'm going to do is think about this as the sine of 45 over the cosine of 45. I'm just going to think about it in terms of degrees. Now the sine of 45 and the cosine of 45 are both going to be equal to the square root of 2 over 2. They evaluate the same thing. So ultimately our answer is 1. The answer is 1. In addition, we should pay attention to the positive or negative of these. This quadrant over here, this quadrant for tangent is a positive quadrant. It is positive in 1 and 3 and then negative in the others. So this is going to be a positive 1. Example 2, we are provided with the tangent of alpha as 1/3 and the tangent of beta as 1/2, and we're asked to figure out the tangent of alpha plus beta. Okay, so what we're going to do is look up that formula. All right, alpha plus beta, that is going to be this one, the one that we derived. Okay, so that would be equal to the tangent of alpha plus the tangent of beta divided by 1 minus the product of tangent alpha and tangent beta. The really cool part here is that they're telling us what the tangent of alpha is, that it's 1/3. We don't have to figure out what alpha is. We don't need to figure out what that angle is and then substitute it in here. You can actually just substitute the 1/3 in for tangent alpha. So that's going to give us 1/3 plus 1/2. That would be tangent beta over 1 minus the product of those two fractions. We don't really need to do any trig. We're just really using our formula to translate this into a form that doesn't have the alpha and the beta together. All right, so now that we got all these filled in, we're just going to do general math, okay? We're going to add two fractions, 1/3 and 1/2. That would be equal to 5/6. That would turn out to be 5/6. I would need to multiply top and bottom here by 2, top and bottom over here by 3, so we get 2 plus 3, which is 5/6. On the bottom, we're going to get 1 minus, the product here is 1/6. That actually turns out to be the same thing as what we have on top. That's the same thing as 5/6. So overall, this is equal to 1, just like our last answer was. Example 3, let's evaluate the tangent of 165 without a calculator. All right, to do that, we're going to need to focus on our special angle measures. Okay, we're going to focus on our special angle measures. What I'm first going to do is think about how I could create 165. One thing that I consider first is how far is that from 180, which is 15 degrees, right? But 15 degrees isn't a special angle measurement, so I might not want to look in the direction of subtraction to create that value, but instead maybe addition. For example, I could do this. I could think of it as the tangent of 120 plus 45. Now 45 is one of our special angle measurements. We know a lot about that one. Okay, 120, that is like one of our special angle measurements. It has a reference angle of 60 degrees. This is 60 degrees away from 180. And since we know things about 60 degrees, these would be two good angles to use to break this up. All right, now let's go ahead and talk about what these actually evaluate as. So we can find those values, and then later we can just substitute those values into the formula. 120 degrees is going to put us over here into quadrant 2. That would be a negative quadrant for tangent. Okay, tangent is positive in 1 and 3. It would be negative over there. So keep that in mind. We also have a reference angle of 60 degrees. Okay, so the tangent 20, I'm going to think of that as being a negative answer first. It's going to be a negative, and I'm going to use my reference angle of 60 degrees along with the identity that the tangent is the sine divided by the cosine. Okay, so all of this right here should evaluate to be the same thing as the tangent 120. We got a negative, we broke it up into sine and cosine, we used our reference angles as well. All right, so the sine of 60 is going to be equal to the square root of 3 over 2. The cosine of 60 is going to be equal to 1/2. We also have that negative. All right, so all of that, the 2's will, in a sense, cancel out. You could do keep, change, flip, but the 2's will cancel out, and we get the square root, or the negative square root of 3. That's what we get for the tangent of 120. All right, now the tangent of 45. Tangent of 45, that one is going to be the same thing as the sine of 45 divided by the cosine of 45. Of course, both of these will evaluate as square root 2 over 2. So that means that this is equal to 1. And of course, it's positive because we're in quadrant 1. All right, so we've got values for tangent 120 here and tangent 45 here. Now what we're going to do is think about how we broke it up. We broke it up as an addition. We did an alpha plus beta. Okay, we did alpha plus beta. So we can rewrite, let's break this up a little bit here. We can set this up as the tangent of alpha plus the tangent of beta divided by 1 minus tangent alpha, tangent beta. And we have all of these values with these two. Okay, so the tangent of alpha is going to be the 120. The tangent of alpha is going to be negative square root of 3. We're going to say plus 1. All right, and then we're going to divide this by 1 minus. Okay, right here, that would actually be a negative square root 3. So it could cancel that into a plus 3. And of course, tangent beta, or tangent 45 is 1, so it doesn't really change anything here. All right, now we need to do a little bit of cleaning up. The top part here, you could just rewrite that and make that part look a lot better. We could just start with the 1 and then say minus the square root of 3. And we'd have 1 plus square root of 3 on the bottom. So at least that part makes it look nice. Unfortunately, we run into one other problem, which is that we have a radical in the denominator. So we're gonna need to fix that one. We're gonna need to change that one up. All right, since I don't really have much space on my paper, I'll go ahead and do that on a separate page. All right, so what we've got is 1 minus the square root of 3 over 1 plus the square root of 3. And the problem here is this square root of 3. We don't like that one. Okay, so what we do is we multiply by the conjugate of the denominator. That would be 1 minus the square root of 3. All right, so we're gonna multiply the top and bottom by that amount. On the bottom, when you multiply conjugates, the middle terms when you do all your distribution are gonna cancel out. So you're gonna get 1 times 1, which is gonna be 1. You're gonna get a 1 times negative root 3, but you're also gonna have a 1 times positive root 3, so those will cancel with each other. Okay, so we'll leave that out. We're then gonna have positive root 3 times negative root 3, which is gonna give us a negative 3. That will cancel out the square root, but you are gonna get a negative for that part. All right, now for the top, you don't have anything that just cancels out because these aren't conjugates with each other. Okay, 1 times 1 is 1. 1 times negative root 3 is gonna be negative root 3. You're gonna do that again, negative root 3 times 1. So you get another one. All right, and then the negative root 3 times negative root 3 gives you a positive 3, regular 3 there. All right, regrouping everything that we've got. 3 and 1 is gonna give you 4. These are gonna give you negative 2 or minus 2 square root 3. The bottom is gonna give you a negative 2. And then we can reduce by a factor of 2. In fact, we can reduce by a factor of negative 2, and that will give us negative 2 for that part here, for the 4 and the negative 2. These will sort of cancel out, but you're gonna say plus the square root of 3. And that would be equal to the tangent of 165. All right, so let's check it out. Tangent 165 set in degrees gives me that value. The claim is it's gonna be this. All right, negative 2 plus the square root of 3 is equal to the same thing.
Wait, what?